We'll just quickly see few more topics related to Docker. So Docker run, then demo advanced Docker run features, and then one more lab. So we want to do the second lab. Second lab, I'll leave it to you to do it at home after this session is over. So we'll quickly see what it teaches in these two lessons, and then we'll stop the session. Okay, I kept it his video and not mine because mine will be pretty much complex.
We will now look at some of the other Docker run commands. At the end of this lecture, you will go through a hands-on quiz where you will practice working with these commands. We learned that we could use the docker run Redis command to run a container running a Redis service. In this case, the latest version of Redis, which happens to be 5.0.5 as of today. But what if we want to run another version of Redis, like for example, an older version, say 4.0? Then you specify the version separated by a colon. This is called a tag. In that case, Docker pulls an image of the 4.0 version of Redis and runs that. Also, notice that if you don't specify any tag as in the first command, Docker will consider the default tag to be latest. Latest is a tag associated to the latest version of that software, which is governed by the authors of that software. So as a user, how do you find information about these versions and what is the latest? At dockerhub.com, look up an image and you will find all the supported tags in its description. Each version of the software can have multiple short and long tags associated with it, as seen here. In this case, the version 5.0.5 also has the latest tag on it. Let's now look at inputs. I have a simple prompt application that, when run, asks for my name, and on entering my name, prints a welcome message. If I were to Dockerize this application and run it as a Docker container like this, it wouldn't wait for the prompt. It just prints whatever the application is supposed to print on standard out. That is because, by default, the Docker container does not listen to a standard input. Even though you're attached to its console, it is not able to read any input from you. It doesn't have a terminal to read inputs from. It runs in a non-interactive mode. If you'd like to provide your input, you must map the standard input of your host to the Docker container using the -i parameter. The -i parameter is for interactive mode, and when I input my name, it prints the expected output. But there is something still missing from this: the prompt. When we ran the app, at first, it asked us for our name. But when Dockerized, that prompt is missing, even though it seems to have accepted my input. That is because the application prompts on the terminal, and we have not attached to the container's terminal. For this, use the -t option as well. The -t stands for a pseudo terminal. So with the combination of -i and t, we're now attached to the terminal as well as in an interactive mode on the container. We will now look at port mapping or port publishing on containers. Let's go back to the example where we run a simple web application in a Docker container on my Docker host. Remember, the underlying host where Docker is installed is called Docker host or Docker engine. When we run a containerized web application, it runs and we are able to see that the server is running. But how does a user access my application? As you can see, my application is listening on port 5000. So I could access my application by using port 5000. But what IP do I use to access it from a web browser? There are two options available. One is to use the IP of the Docker container. Every Docker container gets an IP assigned by default. In this case, it is 172.17.0.2. But remember that this is an internal IP and is only accessible within the Docker host. So if you open a browser from within the Docker host, you can go to http://172.17.0.1:5000 to access the IP address. But since this is an internal IP, users outside of the Docker host cannot access it using this IP. For this, we could use the IP of the Docker host, which is 192.168.1.5. But for that to work, you must have mapped the port inside the Docker container to a free port on the Docker host. For example, if I want the users to access my application through port 80 on my Docker host, I could map port 80 of localhost to port 5000 on the Docker container using the -p parameter in my run command like this. And so the user can access my application by going to the URL http://192.168.1.5:80. And all traffic on port 80 on my Docker host will get routed to port 5000 inside the Docker container. This way, you can run multiple instances of your application and map them to different ports on the Docker host, or run instances of different applications on different ports. For example, in this case, I am running an instance of MySQL that runs a database on my host and listens on the default MySQL port, which happens to be 3306, or another instance of MySQL on another port, 8306. So you can run as many applications like this and map them to as many ports as you want. And of course, you cannot map to the same port on the Docker host more than once. We will discuss more about port mapping and networking of containers in the network lecture later on. Let's now look at how data is persisted in a Docker container. For example, let's say you were to run a MySQL container. When databases and tables are created, the data files are stored in location /var lib mysql inside the Docker container. Remember, the Docker container has its own isolated file system, and any changes to any files happen within the container. Let's assume you dump a lot of data into the database. What happens if you were to delete the MySQL container and remove it? As soon as you do that, the container along with all the data inside it gets blown away, meaning all your data is gone. If you would like to persist data, you would want to map a directory outside the container on the Docker host to a directory inside the container. In this case, I create a directory called /opt/data dir and map that to var lib mysql inside the Docker container using the -v option and specifying the directory on the Docker host followed by a colon and the directory inside the Docker container. This way, when Docker container runs, it will implicitly mount the external directory to a folder inside the Docker container. This way, all your data will now be stored in the external volume at /opt/data directory, and thus will remain even if you delete the Docker container. The docker ps command is good enough to get basic details about containers like their names and IDs. But if you'd like to see additional details about a specific container, use the docker inspect command and provide the container name or ID. It returns all details of a container in a JSON format, such as the state, mounts, configuration data, network settings, etc. Remember to use it when you're required to find details on a container. And finally, how do we see the logs of a container we ran in the background? For example, I ran my simple web application using the -d parameter, and it ran the container in a detached mode. How do I view the logs, which happens to be the contents written to the standard out of that container? Use the docker logs command and specify the container ID or name like this. Well, that's it for this lecture. Head over to the challenges and practice working with Docker commands.
Okay, I guess we'll stop at this instance only because it is getting more and more difficult to continue with my data connection. So we will be not continuing with the contents right now, but since you have the access to this Code Cloud course, what I want you to do in the remaining days of the week, that is tomorrow and day after tomorrow, is quickly go through these two things. So we have done things up to this particular link. Okay, so we have done introductory part, Docker commands, Docker run. I want you to complete up to compose part. Okay, this one. So this is the fifth part. So you complete labs up to this part, that will teach you about how do you exactly create your own Docker. So you have an application, how you containerize it. That is what this will teach, I hope. If the word compose means creation of the Docker, and it also will, the images part will also tell you more about maintenance of images